Hello everybody. Today we are just reviewing some, three questions on the graphical approach of limits and just two more examples to sketch a graph of the function that fits the requirement described below. Only two of those. Okay, that will be short video. Now let's try this one. Do you see the first thing we should do? Read the question. Given the graph of the function g of x below, determine if the statements are true and false. For statements that are false, explain why. Okay, limit x approaches 1 of g of x is equal to. Limit x approaches 1 means like from the left and from the right, when we approach 1, our limit's supposed to be 2. Like the y value is supposed to be 2. So let's try see if that's true. So this is my 1 and I'm approaching from the left. When I approach 1 from the left, my y value is right there, which is 2. So I'm going to write it down. Limit x approaches 1 from the left of g of x is equal to. Now let's try limit x approaches 1 from the right. So this is the right side and I'm approaching 1 from the right side. My y value is, you see, my y value is 1. I should draw these. Okay, when I approach left, my y value is this 2. There. So do you see, guys, see this? Now I have limit x approaches 1 from the right of g of x is equal 1. So you guys can tell limit from the left, limit from the right are not the same y values. Like this is 1 and that one is 2. It means the limit does not exist. That's false. Okay, so I'm gonna say that's false. And since they said when it's false, explain why. So I'm gonna say limit x approaches 1 from the left of g of x is not equal limit x approaches 1 from the right of g of x. That's my explanation. Done. Let's try next question. Question number 9 said, and I'm going to erase all of that stuff so we can answer question number 9. Now question number 9 is limit x approaches c. This c could be any number, any x value. G of x exists for every value of c on the interval -1 and 1. Okay, so I don't know what c is. They said any x number. Any x number would be c. So let's try -1 and 1. This is -1, that's 1. So if you pay attention, like this graph, this is 1 and that up here. So we are talking about actually this graph, the one up here. So they said any number, real number, like x equals c. So if I pick any c here, like between -1 and 1, any c, is the limit exist for those values? Yes. Look at the graph. It's continuous function. There is no vertical or horizontal asymptotes, not like real jump or anything like that. If I pick this c, is the limit exist? Yeah, the limit is 1. If I pick this c, if I pick that, if I pick this, I pick this, anywhere I pick between the -1 and 1, limit does exist. You know, even the whole, the limit exists, we pick arbitrarily close because there is no jump, no vertical asymptote, like it's not going to infinity anywhere. Okay, so that's true. And I don't have to give them explanation for the true part. Okay, let's do erase this and answer question number 10. Limit x approaches 2 of g of x does not exist. They said does not exist. So I don't know. Let's see. Limit x approaches. This means I'm approaching from the left and from the right both. Okay, when they don't mention any sign, it means I'm talking about both. So x approaches 2. This is 2. I'm going to find x approaches 2 from the right. This is the right. When I approach 2 from the right, My y value is, I mean, the graph, I do have a point there, but they're not talking about like what is the point. They are asking for the limit. Limit, you have to pick the graph. So the x approaches 2 from the right side, and my y value is 1. Do you guys see this? So I can say limit x approaches 2 from the right of g of x is equal 1. Now let's try another one from the left. X approaches 2 from the left. I'm coming from the left, and you know it's right there again, 1. So I can say limit x approaches 2 from the left of g of x is also 1, which means limit exists at x equal 2. But they said the limit does not exist, so that's false. Okay, limit does exist. You're going to say because limit x approaches 2 from the left of g of x is equal limit x approaches 2 from the right of g of x, and both of them are equal 1. So yes, limit does exist. But since they said does not, then it's false. Okay? And I gave them the reason. Now these are just the review that we did a few videos on graphical approach. Let's try and graph this. Sketch a graph of a function that fits the requirements described below. Okay, everybody can do their own way how to make a graph, what do we do, and all that stuff. You just pay attention what I'm doing and how I'm going in order, probably. You see, this is a point, right? That's a point. It's a defined point. When I have a x, I do have a y value for it, which means it's a closed circle. Defined point, closed circle. I have a 1, x is 1, and y is also there 1, which means I do have a y. So 1, 1. So this is 1, that's 1, which means my point is right there, and it's a closed circle. This is what I graph first. Then I can go back here. They said limit x approaches 1. This is 1. From the left is 3. So I can just, you know, at 1 they said it's 3 right there, 3. Since I already have 1 point, defined point, so I can make a hole there. You can have like several defined points. It's just we already got 1. That's why I do this first. So I'm going to make a graph, for example, that's a 3, something like that. See, limit x approaches 1 from the left. The y value is 3. Okay, we're good. Limit x approaches 1 from the right. This is a right side. When I approach 1 from the right, they said it's -1, which means my limit's supposed to be here, -1. And I'm going to make a hole right there. And we can make something like this. You see that? When x approaches 1 from the right, the limit is -1. When x approaches 1 from the left, the limit is 3. We're good to go. That's how it looks. Okay, let's do this one. When I see infinity, I know there is a vertical asymptote somewhere. But let's, again, I'm going to do the point first. F of 2 is undefined, which means this is my x value, and undefined means it's a hole for y. I don't have a y value for it. So that's 2, and the y value is undefined. So on x equal 2, it's not there. But the limit x approaches 2 from the left and right does exist. Okay, so what I'm going to do, I'm going to make this 0 on top of 2. It's undefined, but they said the limit does exist. So I'm going to make left and right limit 1, so it means it exists. I'm going to just make like this and like that. You see, x approaches 2 from the right is 1. X approaches 2 from the left is 1. So the limit does exist. Okay, so I answered this portion. Let's try this. Limit x approaches -2 from the left. This is -2. When I approach from the left, I should go -infinity. If that's the case, you know it's going to go something like this. Okay, watch. I approach -2 from the left. That's -2 from the left. And it says when you get to -2, from the left, you are going -infinity. -infinity goes in the bottom, right? This. Do you see that? Okay, that's not okay. I should have, hold on. When I approach -2 right there, I'm not really approaching, okay, like right there, then I have a -2. And since this -2 is going to negative infinity, it means I have a vertical asymptote at -2. And I already said when I see infinities, there is asymptotes. There you go. So this is the graph that is going to negative infinity, and it's not crossing the -2. So that's a vertical asymptote. Okay. X approaches -2 from the right is approaching positive infinity. So if I'm approaching here, I'm supposed to go in this direction. So why don't we just extend this and it will look like nice thing. You see that? I'm just making it up. I don't know what kind of graph is that. So if I approach -2 from the right side, it's going positive infinity. There you go. It's good. I mean, it's not that bad either. So this is what it is. When I see infinities, just make sure that probably you have somewhere asymptotes, whether it's vertical or horizontal. Okay, so this is what it is. Let's do this one. In exercise 11, does limit x approaches 1 exist? No, it does not exist. You can tell limit x approaches 1 and explain why or why not. So I can tell them up here, it says limit x approaches 1 of g of x does not exist because limit x approaches 1 from the right of g of x limit x approaches 1 from the left of g of x. So the limit doesn't exist because I don't have a same value, y value from left and right. So this is how it goes, guys. If you guys have any question you don't understand, please write your name there and tell me that you are not understanding which part, which question, then I can do, I can work with you one-on-one on Zoom, or I can help you out or make another video for you and with another simpler explanation. Okay, have a good day, guys. Bye.